All right, welcome, welcome. Today we're going to be going through the 2015 paper 2, nice and easy. So question 1. Question 1 start by telling you that let P and Q be two propositions, and it says state the inverse and the contrapositive of the statement P implies Q. All right, so you have the statement. They give you the conditional statement. The conditional statement is given as P implies Q. P implies Q. That's the conditional. So to write down the inverse is just not P implies not Q. Not P implies not Q. That's the inverse. And then they also ask for the contrapositive. They ask for the contrapositive. And remember, the contrapositive is logically equivalent to the conditional. So this is the contrapositive. Contrapositive is not Q implies not P. That is the contrapositive. Nice and easy. Not Q implies not P. All right, so now we gave them the conditional, we gave them the inverse, and we gave them the contrapositive. And we know that the conditional is logically equivalent to the contrapositive, and also the inverse is logically equivalent to the converse. All right, we know those things. Nice and easy. All right, let's look at the next part of the question. So this is part 1. Nice and easy. The next part says copy and complete the table below to show the truth value for P implies Q and not Q implies not P. So they're pretty much asking you to show that the conditional is logically equivalent to the contrapositive. Let's go ahead and do that. Show that so first let's complete the table. Let's put the table here. We have our two propositions P and Q. Then we have not P in this column. Then we have not Q. Then we have P implies Q. And we have not Q implies not P. So this takes care of all of them. All right, excellent. So we have P, we have Q, we have not P, we have not Q, we have P implies Q, and we have not Q implies not P. The good thing is they already filled out the table for us with the truth values for P and Q, which makes it very easier. So you know you have true, true, then false, false. Then you have true, false, true, false. Now you want not P. What's going to be not P? Not P is when you negate P right here, the negation of true, let's put it in burgundy. The negation of true is false. The negation of true is false. The negation of false is true. The negation of false is true. For not Q now, the negation of true is false. The negation of false is true. The negation of true is false, and the negation of false is true. Good. Now for P implies Q. P implies Q is false only when P is true and Q is false. So if P is true and Q is false, then P implies Q did not take place. So this is the only time P implies Q is false. Everywhere else it is true. All right. And then not Q implies not P. Not Q implies not P is false whenever not Q is true, but not P is false. That's right here. And so this is the only time it is false. Everywhere else it is true. All right, so that's that. So what does this mean then? This means that, as we can clearly see, that from these two truth results, from the column of the truth results, we can see that P implies Q and not Q implies not P. Since they have the same truth values, then clearly we can say that they are logically equivalent. All right, so this is just the truth table for part 2. Let's look at what part 3 asks. Part 3 says, hence, state whether the compound statements are logically equivalent. Yes, they are logically equivalent. So let's state that here now. So part 3. All right, let's fit part 3 up here. Hence, from the truth table results, we can see that P implies Q, P implies Q is logically equivalent. P implies Q is logically equivalent to not Q implies not P. Nice and easy, soft. From the truth table, we can clearly see this. All right, clearly from right here, they are the same. All right, so you can put it right here, the same. All right, nice. Now let's look at part B.